Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class I will teach you the elasticity. This is the best for class 11 as well as NEET Physics and JEE Main and Advanced. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. So elasticity, what is elasticity? Elastic property is when an external force is applied for small deformation, then body extends somehow. Now if the external force is withdrawn, then body regain its original position. So if an external force is applied, then body extends somehow, and if this force is withdrawn, then body regain its original position. So what is elastic property? Suppose this is the object and the external force is applied, then the body extends somehow, and if external force is withdrawn, then body regain its original position. So the property of the body to regain its original position is called the elastic property. Now when an external or elastic property, we use two terms. One is stress and another term is strain. Two important terms, stress and strain. What is stress? Suppose an external force is applied on a body. Now an internal restoring force is developed at each section of the body, which, suppose this area is A, an internal restoring force is developed at each section of the body which restores the body to its original position. Now this internal restoring force per unit area is called stress. What is stress? Internal restoring force by area. Now that is R by A. R by A is equal to stress. Now as R equal to F, then we call stress equal to external force by area. So if we draw the free body diagram, then this is F. So F, R, F. As the body is not in motion, so F equal to R equal to F. So internal restoring force is equal to external force. So R by A means F by A. Now there are two types of stress. Two types: shear stress and another is normal stress. Stress is denoted by sigma and strain is denoted by this. Shear stress and normal stress. Suppose a body is, this is a body, and if force is act in this way, so a force is act at an angle theta. Now suppose this area is A. Now here component of the force along this direction, along the tangent, is F cos theta, and in this direction is F sin theta. Now shear stress means the stress which act on the tangentially along this. So shear stress will be F cos theta by A, and normal stress will be F sin theta by A. That is stress developed normally. That is normal force causes the normal stress and tangential force causes the shear stress. Okay, this is a force. Component of the force along the tangent direction is F cos theta, and along the normal is F sin theta. So tangential force develop the shear stress, that is F cos theta by A shear stress, and normal direction force, normal force develops the normal stress. Now shear stress is denoted by sigma T and normal stress is sigma N, or sometimes it is sigma X and this is sigma Y. The body is attached in a wall. Suppose this is a rod is attached in a wall, and a force is applied on the bar. So if due to force applied, suppose this is the original length, and due to force applied and extension del L is developed. Due to extension and del L is developed. So this cross section area is A. Actually this is like this way, this way. This cross section area is A. This cross section area is A. This cross section area is A. Now force per unit area is stress. So stress is denoted by sigma, which is equal to force per unit area. This is the cross sectional area. This is stress, and strain is defined as increase of length by original length. Increase of length divided by original length. Okay, that is del L by L. Del L by L. Strain is defined this. Strain is denoted by small epsilon. Strain is denoted by this symbol del L by L. This strain. Now we apply Hooke's law within elastic limit. Within elasticity, that is for small deformation. For small deformation of body, stress is proportional to strain. This is the Hooke's law. That is, as we apply less stress, then less increase of length occurs, so less strain develop. And if we apply more stress, then more increase of length occurs, so more strain is developed. That's why we call stress is proportional to strain, and this stress is proportional to strain after within a small deformation, within the elastic limit. Suppose if a large amount of force is applied on a body, then the body permanently deform. Suppose this is a spring. If large amount of force is applied on the spring, then the body is permanently deformed. It cannot regain its position. So we apply the force within a elastic limit, that is a certain within the small deformation. Within the small deformation, stress is proportional to strain. Okay. Now, so stress equal to one constant term, strain. Now K equal to elastic modulus, which is equal to stress by strain. So elastic modulus equal to stress by strain. Now there are three types of elastic modulus. We will study three types of elastic modulus. Elastic modulus, three types. Denoted by Y, and second is Bach modulus, B-U-L-K, Bach. Second is Bach modulus, M-O-T, denoted by B, and modulus of B. Modulus of rigidity is denoted by eta. So three types of elastic modulus. Elastic modulus means stress by strain. Now for Young modulus we use longitudinal stress by longitudinal strain. Suppose this is a bar, a force is applied at here, length is L, and increase of length, suppose del L, this is original length, del L is increase of length. Now force is applied at here, F. Now what is Young modulus? Young modulus equal to longitudinal stress by longitudinal strain. Longitudinal stress, which the stress is the normal stress. Normal stress is called longitudinal stress, that is which increase the length. Is called longitudinal stress. Normal stress. Actually, this is normal stress. Longitudinal stress here. Longitudinal stress will be this force. Due to this force, length is increased. So longitudinal stress will be force per unit area F by A. This is longitudinal stress, and longitudinal stress is increase in length by original length. So del L by L, del L by L. So this is denoted by Y, Young modulus. Y equal to this. Formula is this. From this we get F into A del L into L. So del L equal to F by A by longitudinal stress equal to del L by L, which is equal to F L A into del L. So from this we get del L equal to F into L by A into Y, by A into Y. So this is very important. Important formula: increase of length equal to F into L by AY. L is original length, H cross section area, this cross section. AY is Young modulus. So this is a formula. Now what is Bach modulus? Bach modulus is when an uniform pressure is applied on a volume, spherical volume, on a spherical body. Suppose here a elastic ball, that is suppose rubber ball. Some air is present here. If an external uniform pressure is applied, then the volume will be decreased. So this volume, suppose decrease in volume is del B, and original volume is V. Now here we use excess pressure, we use del P. When an excess pressure, suppose there is a pressure within the ball, and if the inside pressure and outside pressure is equal, then we cannot decrease the volume. But if an excess pressure is act on the ball, then the volume of the ball will be decreased. So here we use excess pressure, del P equal to change of pressure or excess pressure. Student makes confused that this is a pressure. This is not absolute pressure. This is pressure difference. That is pressure difference of inside and outside. Pressure difference of outside and inside. This is called change of pressure or excess pressure. Now here, due to excess pressure, a volume is changed. That is, here volume is decreased. If pressure is applied on the rubber ball, V is original volume. Now what is Bach modulus? Bach modulus is defined as volume stress, that is normal stress. Here normally pressure is applied, so normal stress divided by normal strain. Volume stress by normal volume strain. Volume strain means decreasing volume by original volume. So normal stress by volume strain. Normal stress we define normal stress as volume stress. Volume stress by volume strain is Bach modulus. Now what is normal stress here? Normal stress equal to del P, and decreasing volume is del B by original volume V. Here we use minus. So Bach modulus equal to, because pressure applied, this volume is decreased, and if del P is increased, then del B is decreased. If del P is negative, then del B is positive. So that's why it is negative. Bach modulus equal to, so this is an important formula, minus del P into V by reciprocal of Bach modulus K, compressibility equal to reciprocal of Bach modulus 1 by B, which is equal to minus del B by V into del P. This is compressibility. So compressibility is defined as the change in volume del B. K equal to del B when V equal to 1 and del P equal to 1. That is, compressibility is defined as the change of volume when a unit excess pressure unit excess pressure is applied on unit volume of a body, then change of the volume is called the compressibility. Okay. So for modulus of rigidity, we draw this book is present and an external force is applied on the surface of the book. Now this upper surface will tilt somewhat. The upper surface will tilt somewhat. That is, here a angle is formed. Now this angle theta is called shear strain. Theta is called shear strain. And book, I have drawn a book. This is a book, and a tangential force is applied on the surface of this book. Now the upper surface will be tilted by little amount. So theta, this surface will make an angle. You can experiment this when an external force, when a tangential force is applied on the surface of a book, then the book tilts, a angle is formed this way. Now this theta is called shearing strain. Theta is called shearing strain, and a tangential force, AP is tangential force applied, which is called shearing stress, force by area, tangential force applied. Now F by A is called force by area. What is the area? Area of this surface ABC. A equal to area of surface ABCD. Surface ABCD. Area of surface ABCD. Now F by A called shearing stress. Suppose this is del x. That is, this is del x, and distance between two surfaces is L. So here, suppose initially the surface is ABCD, and finally when the tangential force is applied, after the tangential force applied, that is AB line shift to A dash B dash, and CD line shift to C dash D dash. That is, the surface ABCD. Sorry. Suppose the surface ABCD shifted to A dash B dash C dash D dash. Surface ABCD shifted to AB. The line AB shift to A dash B dash, and the line CD shift to C dash D dash. So the surface ABCD now will be the surface A dash B dash C dash D dash. So this angle is theta formed. Theta is shearing strain, and F by equal to shearing stress. Now as tan theta equal to, here from here tan theta equal to what? Del x by L Now as theta is small, tan theta equal to theta, so theta we can write del x by L. Now modulus of rigidity is defined as shearing stress by shearing strain which is equal to shearing stress. What? Shearing stress equal to F by A and shearing strain equal to theta. Now for theta we write del x by L, so this is F L by A into del x. Here L is distance between two surfaces, not length. Here L equal to distance between two parallel surface, and A is surface area. A equal to upper surface area, and del x is equal to shift of this line. This is del x. F is tangential force. F equal to tangential force. Important term is Poisson's ratio. Next term is Poisson's ratio denoted by sigma. What is Poisson ratio? Suppose this is a rod, length is L and diameter is D. Now an external force is applied on the two end of the rod. So if an external force, if two external, suppose this force is applied at the two end of the rod, then what happens? Length is increased by L plus del L and diameter will be decreased D minus del D. So as volume remain constant, if length is increased, then diameter will be decreased. Now here two strain occurs. One is longitudinal strain, another is shear strain. Longitudinal strain equal to del L by L, and lateral strain equal to del D by D. As D is decreased, here we denote minus del D by D. Magnitude is del D by D. Now Poisson's ratio is defined as Poisson's ratio sigma equal to longitudinal strain. The sigma is defined as lateral strain by longitudinal strain. Lateral is up. Lateral strain in the numerator and longitudinal strain in the denominator. So you remember this longitudinal strain. So lateral strain is minus del D by D and longitudinal strain is del L by L. So this is the formula of sigma, Poisson's ratio. Poisson's ratio is defined as minus del D by D. What is del D? Del D is decrease of diameter and del L is increase of length. L and the L is original length, D is original diameter, initial diameter. Now value, the theoretical value of sigma lies between sigma less than half greater than minus half. This is the theoretical value, but practical value of sigma is sigma less than half greater than 0, not negative. Practical value is this, 0 to half, minus 1 to half. Theoretical value, it can lies between minus 1 to half, but practical value is this. For a body, there are defined atoms arranged in a regular manner. If R0 is distance between two atoms, suppose this is R0 equal to distance between two atoms, and Y equal to Young modulus, then interatomic force constant, constant K is defined as Y into R0. You remember just as a formula. Interatomic force constant equal to Y into R0. Y equal to what? Young modulus. R0 equal to distance between two atoms. Okay. Now Now most important topics is what done in stretching a wire, or what done for first we calculate what done in stretching a wire, then we calculate what done per unit volume of the wire. Suppose this is a wire, by applying a force we extension is del L, applied force is F. Now here force F, applied force varies with increase of length. Remember this point, this theory applies force. This force is not constant. As we increase the wire, when we increase the wire, then force also to be increased gradually, not constant. Force applied varies with increase of length. That is here, if we stretch the wire, then force applied also have to be increased. Now, so a variable force is applied. Now what is the work done? So work done W equal to, we apply for variable force, we can apply average force into displacement del L. So this is easy. Average force, first initially force is 0, and finally when the extension is del L, when increase of the wire is del L, then the force is F. That is F is at the end maximum force. When increase of length is del L, at that moment force is F. Remember this point, this when increase of length is del L, at that moment force is F. F is maximum value. So average force equal to 0 plus F by 2 into del L. Now that is half into F into del L. This is the work done. Now we know y equal to, if the cross section remain constant for a small deformation, suppose for small deformation area is constant. Now for small deformation we y equal to, formula is F by A into del L by L. This is now F equal to A y del L by L. So we can write half F equal to A y del L whole square by this, F equal to A y del L whole square by L. So this is the formula of work done. Half, just put y equal to this. Now so work done equal to, we get this formula, half F into del L. Work done per unit volume of wire, equal to W by V. Now work done equal to half F into del L. Volume equal to what? Area into length L. Now half F by A equal to stress into del L by L equal to strain. So work done per unit volume equal to half stress into strain. If you remember this formula, work done per unit volume equal to stress into strain, half stress into strain. Work done per unit volume is called energy density. If you remember the formula, work done per unit volume equal to half stress into strain, then you can also work done equal to half stress into strain into volume. Now this is important. Work done per unit volume equal to half stress into strain. Now Young modulus also stress F by A by strain, L del L by L, that is stress by strain. Now if we convert whole term for y del L, F by A is not present, half into del F by A stress into strain. Strain is del L by L. Now half into F by A. F by A equal to what? Y into del L by A. Y into del L by L whole square. So this is the one expression. Here F by A is not present. Sometimes del L by L is not present. So when del L by L is not present, so from this we can convert, we can eliminate del L by L from this relation. Del L by L equal to F by A into 1 by Y. So half F by A whole square into 1 by Y. So these are the different expression of energy density. So these are the different expression of energy density. Graph, stress, strain, graph. If we draw, this is stress, this is strain, stress versus strain. If we draw stress versus strain graph, and how we stress versus strain graph, suppose this is a wire and some weight, there are some weight present. Now we placed the weight one by one gradually. We placed weight at the end of the wire one by one, and we notice the increase of length of the wire, and we notice the increase. If we record the increase of length of the wire, if we put the weight gradually at the end of the wire one by one and study the increase of length according to that, and for different value of weight, that is weight means stress, for different value of stress, different strain. Strain means increase of length by original length is strain. So if we record the increase of length, then we get the strain, and weight we get the stress. So by stress we can now draw the stress strain graph. For different stress, different strain we get, then we draw the stress strain graph. Now what is the stress strain graph? We first, stress is proportional to strain. First we get the stress is proportional to strain. This is up to certain limit. After that, if little stress is applied, then a point is reached like this way. Now this is the proportional limit up to which stress is proportional to strain. So at P point, P is proportional limit at which stress is, up to that stress is proportional to strain. If a little stress is applied beyond the P, then a point is reached. Suppose this point is E. This is elastic limit. The body has an elastic property up to that limit, but beyond that point, if extra stress is applied, then the body does not behave like elastic property, then it behaves as plastic property. Plastic property means when stress is withdrawn, then it has a permanent deformation. So plastic property is when an stress is withdrawn, when an external force is withdrawn, then the body has a permanent deformation. So after that, the plastic property start, the stress strain graph will be like this. And after this, fracture. So the body can bear the maximum stress at this point. After that, stress is lowered. After that, if an external force is applied but stress is lowered, so this is the maximum stress or ultimate stress. So we defined now at the point E, this is the elastic limit. After that, the body behaves like plastic property. The body behaves like a plastic body. That is, stress is withdrawn or force is withdrawn from this point, then body has a permanent deformation. This amount of deformation occurs. So body has a plastic property beyond E, but within E the body behaves like a elastic property. After E, the body behaves like a plastic property. Body behaves like a plastic body. So elastic limit, E is called elastic limit, and D, the point D is the maximum stress developed. So point D is called ultimate stress. And at here fracture, that is breaks. At this point the body breaks. So it is breaking point or fracture point. here is another point is present C, which is called yield point, which is called yield point. C is called yield point. Yield point. What is the yield point? B and C is very close to each other. Beyond elastic limit, there is a point for a certain stage around C. The body behaves like a fluid body. Fluid. The body, solid body behaves like a fluid. That is molecule of the solid particles behaves like a fluid particles. So this occurs at around the point C. So C point is called yield point, and these ultimate stage or tensile stage, and at the a point breaking point occurs. I repeat once again. So here 1, 2, 3, 4, 5. 5 points are present. 1, 2, 3, 4, 5. Different books, different points are given, but this is actually these 5 points we have to mark. We have to mark the 5 point on stress strain graph. We have to make the 5 points of stress strain graph. First is the proportional limit. Up to that limit, stress is proportional to strain. Is the elastic limit. That is the body behaves as elastic property up to the point E. Beyond E, the body behaves like plastic body, but there is a point beyond E, that is E and C very close to each other. There is a point C at which the body likes as a fluid particles. Molecule of the solid particle behaves like a fluid particle. That point is called yield point. Around C, if stress is withdrawn, then the body has permanent deformation, more deformation, and the body can bear the maximum stress up to D point. So D is the maximum stress. After that point D, stress is now decreased. So D is the ultimate stress or maximum tensile strength. D is called maximum tensile strength. Maximum tensile strength. And at the point A, the body fracture. So this is 5 points you have to remember. So relation between Y, E, eta, sigma, relation between Young modulus, Bach modulus, modular is written, Poisson's ratio. There is a relation between these terms. What is the relation? You remember this formula. The Bach modulus equal to Y divided by 3 into 1 minus 2 sigma. This is first formula. Second formula is eta equal to Y divided by 2 into 1 plus sigma. This is second relation. Third relation is sigma equal to 3 b minus 2 eta divided by 2 eta, okay, 2 eta plus 6b. Third equation. Fourth equation is 9 by y equal to 1 by b plus 3 by eta. So these are the different relation between y, b, eta, sigma. B equal to y by 3 into 1 minus 2 sigma, eta equal to y by 2 into 1 plus sigma, sigma equal to 3b minus 2 eta by 2 eta plus 6b, and 9 by y equal to 1 by b plus 3 by eta. What is the thermal stress? Suppose a rod is supported by two vertical wall. Length of the rod is L. Cross section area is Y. And Y is Young modulus. Now heat is applied at the rod. Heat is applied on the rod. If heat is applied, then the rod will extend. But this is restricted by two vertical wall. Then what happens? The rod try to extend, but the vertical wall resists its extension. So what happens? Now a force you will exert on the wall. So a force is exerted on the wall. This force produced due to thermal expansion. This force produced this side and this side. Force produced due to thermal extension. That is due to heat applied, the rod extends. So a force is applied at the wall. This force by area is called the thermal stress. For this force by area is called thermal stress. This force by area is called thermal stress. Now how can we find the thermal stress? If theta is temperature increase and L is original length, and here we required alpha, one term alpha equal to coefficient of linear expansion, coefficient of linear expansion of temperature, coefficient of linear expansion of temperature, or this, what is alpha? Linear expansion. Now del L here, del L equal to increase of length which is equal to L into alpha into theta. Theta is 10% increase. L alpha theta, del L equal to this. Now what is Young modulus equal to, we know, force by area into increase in length by original length. So F into L. Here F by A is thermal stress, so F by A divided by del L. What is del L? Del L equal to L alpha into theta. Here L cancel. So F by A equal to Y alpha into theta. F by A equal to Y alpha theta. So this is the thermal stress. The formula of thermal stress equal to Y alpha theta. Young modulus, alpha is coefficient of linear expansion, temperature coefficient of linear expansion, theta is a temperature increase, Y alpha theta. This is thermal stress. Now important problem. Suppose a rod of mass M is hanged from a roof. Now this is a rod of length L, mass M. Roof. Find the extension of rod due to its own weight. This is the problem. A rod of mass M and length L is hanged from a roof. What is the extension of the rod due to its own weight? Here no external force is applied. Due to its own weight, the rod extends. What is the extension? So you have to find the del L. Given y is given, mass is given, original length is given. So here students can use the formula y equal to weight F by A. Generally student use the formula y equal to force by area into del L by original length, and put here F equal to mg L A into del y. Del L. mg L A into del L. But this is not correct. Y equal to this. So del L we get. So this is not correct. Because here force is not mg. How? Here force is not mg. Because here a variable force is act. So if a body is in horizontal and if force is applied, then at every section force is F. But here it is hanging vertically. So at this section, what is the force? Acting at this section? The force acting at this section is the zero force. What is the force acting at this section? At this section, force is the weight of the below portion. Weight of this portion act in this section. At this section, weight of this portion act in this section. And at this section, whole weight of the body acts. Here, whole weight acts. So we can average value. So y equal to F average into length by A into del L. What is average force? 0 plus mg by 2 into length del L. So del L equal to this. Del L equal to A y 2AYMGL. So this is the answer. This is the answer. Next problem, in an ocean, the density of the water at the surface is rho. If the pressure difference between surface and the bottom is del P and Bach modulus of the water is B, what is the density at the bottom? Rho dash. Rho dash equal to what? So question is density of water of C, suppose C, of a C, or density of water of C at surface is rho. Bach modulus is B. What is density at the bottom? At the bottom of C is if there is a pressure difference, there is a pressure difference del P is given between surface and bottom. Suppose question is density of water of a sea at the surface is rho. If there is a pressure difference between surface and bottom is del P, what is the density of water of sea at the bottom? Given Bach modulus of water is given. Pressure difference del P is given. This is given. Del P is given. This is given. Rho B del. Now rho dash, that is what is the density of water at the bottom surface? What is the, to solve this problem solution? What is the solution? To solve the problem, we take some amount of water of mass m. Some amount of water of mass m. Now, what is the density? Rho equal to mass by volume. Suppose volume of this portion is V. Now, if this amount of water, consider this amount of water at the bottom, that is whose mass is same and volume becomes different because density different. Now, mass equal to, now what is rho dash? Rho dash will be, what is rho dash? Rho dash will be mass, it will be same, mass by volume, V dash. Now, here with the formula Bach modulus equal to excess pressure del P by change in volume, del B into V. This is the formula Bach modulus. We use the magnitude, not minus sign. We take the magnitude. Now del B is given. So Bach modulus equal to, now what is del B? Into V by del V equal to, V is more, V minus V dash. This is del V. Now V equal to del P. If we divide it by V, 1 minus V dash by V. Now what is V dash by V? If we divide rho by rho dash, we get V dash by V. So V dash by V equal to rho by rho dash. So that is del P 1 minus rho by rho dash. So Bach modulus equal to this. Now 1 minus rho by rho dash equal to del P by V. So rho by rho dash equal to 1 minus del P by V. So answer is rho dash equal to B into rho divided by D minus del P. Every term is given, so this is the formula. This is the answer. If we divide by D, 1 minus del P by D. So this is the formula. Next. Next problem is, suppose two wire, different wire, that is a wire of different material. Suppose this wire is made of iron and this wire is made of copper. Now young modulus and cross section area of different rod is given y1, y2. Now here a horizontal rod is present. Now at which position force is applied? AP is applied. AP is given. Length of the rod is given. This is massless support. Now AP is given. What is the distance from this rod? What is the distance of the force from this rod, such that the two rods remain in equilibrium? So find x for which two rods remain in equilibrium. What is that? So find x, this distance for which this rod remain in equilibrium. Now given cross section area of this rod is given, and young modulus are given, length of the two rods are given, all are given, that is A1, Y1, A2, Y2, L, these are given. Find also a force is given. Find x for which the two rods, no? This massless rod are in equilibrium, massless rod. The question is find x for which this massless rod is in equilibrium, remain in equilibrium. The massless rod remain in equilibrium. To solve the problem, we have to suppose here force acting is different F1, here force acting is different F2. So AP equal to F1 plus F2. This is question. This is extension is same. Extension is formula is y equal to F by A into del L by L. So extension is FL F1 L by Y1 A1. This is the extension. So for this and for this F2 L by Y2 A2. So from these two equation we get F2. We get F2 or F1 in terms of F. Now F equal to F1 plus F2 and another equation is del L. Del L equal to A1 Y1, which is equal to F2 L by A2 L. L is the original length. Okay. This L. F1 by L. So to find the x, we have to take the moment of all the force. F into x equal to, this is positive moment, and minus F to L negative moment. So x equal to F2 by F into L. Now F equal to F1 plus F2, and because F1 plus F2 equal to F, and now extension del L equal to what? Force for FL by Y. This is the formula of del L. This equal to this. Now A2 into Y2. So L1 equal to, from this we get A1 by A2 by F2. Now if we put F1 at here, we get F2. So F2 equal to, from this we get F2. F2 equal to what? F equal to F1. If we put F1 at here, we get F2 plus F2. So F2 equal to F into A2 Y2 divided by A1 Y1 plus A2 Y2. So F2 by F equal to this. So A2 Y2 by So this is the answer. Student, this is the end of the class today. To get more important video of NEET and JEE main exam or advanced exam, watch my another video. Okay, thank you.